All right, grade 12s. Well, I mean, after yesterday's exciting lesson on waves and on two-source interference, um, today more of the same. Yay! Okay, so we've got today. I just wanted to show you something, and the deal is okay with diffraction. Okay, now with diffraction, that's when waves bend around an edge. Okay, now if you have a narrow slit in a wall, let's say a hole in a wall, okay, when the wave crosses through there, okay, it'll bend around both edges, and the smaller the slit, like the smaller the width of the hole, the more like a point source the wave will appear. Okay, so let me show you what I mean here. Now, by the way, a point source, here, let me just move this for a second. A point source looks like this. If I just put a little dot here, okay, and I let that go, see that's a point source. Ignore the waves at the top for a moment. You can see the point source there radiating outwards, okay, bouncing off that wall. Okay, now what I have here at the top are plane waves. They're called straight waves. Okay, now these are crescent troughs. And what's going to happen is I have two holes, okay, in this wall here. You can see there's a wall there, and a wall here, and a wall here. And there's two openings. Now each opening will act like a point source. Well, yesterday we were looking at two-source interference. These two holes, because of diffraction, should look like two point sources, okay, when we do the interference experiment. Okay, so let's show what happens here. You have the waves passing through these two holes, and then the waves bend as they diffract, right, as they pass through those holes. And then what we're seeing here very clearly is the interference pattern that we saw yesterday. Here, let me show you the 3D view. Okay, here we can clearly see the pattern of bands of the areas of constructive interference and destructive interference there. Okay, not sure what happened to the brightness, but anyway, you see like here, oh, it's increasing again. Don't ask me why. I don't think I'm changing anything. It seems to be changing its frequency. But here we can see areas of constructive, like nodal lines. Right here there's a nodal line, and then right here it keeps changing. It's weird. And here there's an antinodal line. Okay, so you get nodal lines and antinodal lines, areas of constructive and destructive interference, just like what we saw with two sources. Okay, now that's significant. Okay, because it's really impossible. Let's say we had a flashlight with two lights. Well, that's not going to produce two-source interference for reasons that I'll explain later. It has to do with the way that the sources have to be. They have to both be emitting crests at the same time, let's say, so they have to be in phase, okay, and with the same frequency and so on. And with ordinary light sources, that's just not possible to do that, okay? But anyway, double slit interference, this is in a ripple tank, so it shows that it works with water waves. But whether it's double slit or two-source interference, you get the same equations. Okay, so I'm going to stop this here.